once again our magnetism. Now, in the magnetism, earlier we discussed what happens when the charge with some kind of a velocity perpendicular to the magnetic field enters into the magnetic field. We discussed the deflection of charge in the electric field also. We discussed everything. Yes. Now, in the uniform electric field, if the charge used to enter perpendicularly or if it was making some angle theta, we saw that this was the situation for the particle. Yes. Today, I will start with one such approach only. One important approach of the magnetic field, that what happens if the initial velocity u, okay, makes some angle theta with to the magnetic field. Okay, what happens when some particle makes some angle u, makes some angle theta to the magnetic field? Now see, let's suppose magnetic field is increasing like this way and the particle has some velocity u which makes some angle theta with our magnetic field. Are you able to get me or not? And this is my charge particle. Let us consider our charge particle which has some mass m. You know that only this velocity can have two components, yes, like u cos theta and u sin theta. Now, as we learned earlier, as you saw, that when there is any initial velocity which is perpendicular to our magnetic field, it makes the particle to rotate in a, yes, rotate in a circular path. So point is, perpendicular velocity component makes the particle to rotate in the circular path. Then what about the parallel velocity component? What it actually does? So parallel velocity component has a use that this parallel velocity component of the magnetic field component does not change. You know that magnetic field does not work on the parallel velocities, isn't it? Yes or no? So change and it carries the charge forward. So basically idea is simple, that when we are looking at our charge particle and when we apply some velocity, then only the velocity which is perpendicular to the charge that takes the particle along the forward direction. Sorry, yeah, only the component which is perpendicular to the magnetic field will rotate the charge, word or not, like this way. And the parallel component will move the charge in the forward direction. Are you able to get me or not? Yeah, it will not change its velocity. So point is, like, let's suppose if I have a charged particle like this way, and it has, this is my magnetic field, and along this side it has velocity as u cos theta. So basically if you look over here, that this u cos theta is parallel to the magnetic field. So basically force by magnetic field, when you apply bqb sin theta, sin theta is 0, so force by magnetic field is also what? 0. And if force by magnetic field is 0, does the acceleration by magnetic field will be 0 or not? Are you able to get me? So basically, if acceleration is zero, what happens? The velocity will not change. So this velocity remains constant. So let's suppose the particle can move in the forward direction or not. So basically, after some time, as it has velocity, the particle will have some x coordinate u cos theta into time t. Yes or no? Because the acceleration is how much? Zero. Correct? Now, the same particle, if it is taken by perpendicular, we know that perpendicular will make the particle to rotate. Yes? So, let us understand the situation that this perpendicular velocity component, let's suppose this is my magnetic field, and this perpendicular velocity component, which is u sine theta, u or v, whatever situation you wanna follow. So basically, you can look over here. The velocity is along which side? J cap. Magnetic field is along which side? I cap. So as I know that magnetic field vector is given as q v cross b. Yes or no? So basically, this means what? Q v is what? V is if I write the direction, then F cap will have direction where force due to the magnetic field will have a direction along J cap cross I cap. Yes or no? Here in this kind of setup. So basically, this is what J cross I is minus K. So it is along minus K cap means along negative Z axis. Yes or no? So basically, the point is simple that when you have a magnetic field like this way, velocity like this way, and if this is my Z axis, okay, the force is along this Z axis. So particle will be along the plane of this Z axis or not? Tell me yes or no. Are you able to get me or not? Then only always the force is along the Z axis of the particle. Are you able to get me or not? So one component of the velocity is making the particle to rotate like this. Another component is taking it forward. So what will happen? This will be the path of the particle or not? Tell me yes or no. And this is called as helical path. What it is called as? Helical path. Are you able to get me? We'll talk much more about that. But let us write this situation then. Basically, this means that there is a circular motion of the particle in YZ plane. Yes or no? Let us denote that circular motion. We'll talk a lot of, we'll talk in a very great detail about this part. Okay. Now, basically, let's divide this. Basically, this is my YZ plane. Which plane it is? Yeah. Are you able to get me or not? Now, particle was over here. Yes. So, how to start with it? Can you draw the motion? Try to tell about what is the coordinate of the particles at every time. T is equal to 0, T is equal to 1, T is equal to 2, something like that. Can you tell? So, let's suppose if the particle starts from here, particle will start from one of the corners. Yes. This is my charge. Then it experiences some velocity and it is minus z. That means it will rotate like this way, anti-clockwise. Yeah. Sorry, clockwise way. Now this is my velocity. With this, the charge starts to move. And this is my time, 0 comma t seconds. Are you able to get me or not? Then what happens? This particle comes over here. Then at exactly t by 4 seconds, it completes half of the revolution. Word or not? Sorry, 1/4 of the revolution. Yes. And at every moment, this what does not change is my over here. If I want to write, let me write it perfectly. This is t by 4, but the velocity will still not change. Let us call it as uh, let us call this as v sine theta. U let us, I'm using u symbol now. Let me use u. So this is also u sine theta. Are you able to get me or not? Here also the velocity is u sine theta. Here also the velocity is u sine theta. So this is the velocity component of the particle along this whole circular path. Are you able to get me? Clear? Now, let us talk about this point. Now, when I consider this center, what is its center basically if you look for? Yes. Tell me the value of center. Uh-huh. 3t by 4. 60. So what will be the coordinate? Now, this center has a radius along which axis? Z axis? Tell me. Yes. And towards which Z axis? Minus Z axis. Yes. Yeah, so the coordinate, x coordinate will be always 0. Y coordinate will be here also 0 because it is starting on the z plane directly. So basically what will happen actually, you try to see. The particle was, if this is x, this is y and this is z. So particle was over here. You started its motion from here with some velocity like this way and then this. So what will happen? Suddenly the particle will shift along minus z axis and then it will start rotating like this. Are you able to get me or not? So this is why its y component is how much? 0, but z component is minus r. Are you able to get me or not? So at any time, if I want to find the at any time if I want to find the coordinate of the particle, then this is some angle phi which the particle will travel in time t or not. Yes, and then if I can construct a right angle triangle on it, and if this is radius r, then this is what? R sine phi. Yes, and this is what? R cos phi. Are you able to get me or not? So let us write all these things. So we have a motion in the circular path. Time is time of the particle, time of traveling, means total time period in one rotation. It is this time. And it is changed basically. First, let us define radius. So the first quantity which we define is radius of the circular path. So this is it is mv, yeah, mv sine theta by qb. Yes. Second, the time period is still same 2 pi m by qb because time period is independent of velocity component or something like that. Now, angular frequency of revolution 1 by time period, which is 1 by frequency, which is qb by m. Are you able to get me or not? So therefore we can define position of particle at any random time as, okay, let's define our position of the particle at any random time. Therefore, x coordinate is always 0, yes. Y coordinate is r sine phi, already we can see. And then we have the z coordinate. Z coordinate is what? What will be my z coordinate? Tell me. Z coordinate is, from where you are starting your calculation, where the charge starts, here or not. So z coordinate, you can see that every time the z coordinate is decreasing or not. Earlier it was at radius r, yes or no? Then it decreased to r cos phi. So net z coordinate will be what? Z coordinate must be taken from here now. Yes, because here also this center is at itself z coordinate. Word or not? Okay. So this is my origin. This is my origin 0 comma 0 comma 0. So perpendicular is r sin phi. This basically this is my z coordinate or not? Tell me yes or no. Z is what? Minus of r minus r cos phi. And what is this phi? Phi, if it is rotating with angular velocity omega and time is t, so phi is omega t or not. So y coordinate is r sine omega t and z component is minus of r minus r cos omega t. That's the coordinate equation of the particle at any time t. Are you able to get me or not? Z, how come it is x? The particle root x coordinate, no, no, it is z, z. Okay, clear? Yeah. So what can be the maximum distance of particle from x axis? This is my x axis origin. So maximum distance it can go on z axis as 2r or not. And in radius, yeah. So it is not r. Remember that in helical path, the maximum distance is not radius r, it is 2r. Are you able to get me or not? And our charge, the important quality of the charge is charge touches our x axis after completion of every time period t. Is it clear or not? Charge touches our x axis. Charge does touch the x axis or not? Yes. After completion of every time period t. Yes. It comes at the origin once again or not? So basically you can think like that this is some kind of, you can treat like as, so this was just talk about the vertical component, means just about the vertical velocity which we talked about right now. Now if we combine this horizontal velocity and vertical velocity, then we get a combined motion or not. Therefore the combined motion of charge, let me take some pictures 1 minute. uh, yeah, magnetic effect of current. There is magnetism. So these kind of questions now you can handle, yes or no? Like two coils placed in inside it. These are the common questions which are asked usually. Go ahead or not? Okay. So you can follow this theory book also, or that theory book which I have forwarded to you. Here, this diagram which is very very important. Position of B versus X for the ring case. Go ahead or not? Okay. What happens? You see there is a semicircle over here, but then it is suddenly changed over here. Go ahead or not? So we'll talk about that. Got it or not? Two coil situation, Helmholtz coil. We'll come on that. Don't take tension. We'll have to still come on that. Okay. Now, solenoid, how there is a variation of magnetic field in the solenoid. These things are very, very important to understand. Okay. Every time, whenever you get a time, you focus on this, work on it, try to understand the situations. Okay. Where is that? Nothing is given. Okay, I'll take this picture. One minute. Search over here. And okay. So this is what I was talking about. That when you consider the movement of charged particle, you see, can you see that properly? That first gets stretched out. You can see now. So that's what I'll write. The combined motion of the charged particle is a helical path. You can see that the charged particle first gets stretched along the z-axis. So maximum displacement this is what 2r. Not on y, sorry, on z-axis it is 2r. Are you able to get me or not? And every time you can see that the charge is touching our x-axis or not. So which velocity actually takes along this direction? It is that v cos theta, which we talked about it. Okay. Yeah. And which velocity makes it rotate? It is yeah v sin theta. Are you able to get me or not? Is it clear? Now, basically, between whenever the particle touches one of the x-axis, we define this displacement between two circular rotations as pitch. What we call it as? Yeah, pitch of the helical path. Are you able to get me or not? Okay. Now, so let us find out what can be this pitch. So let us define this quantity. Pitch of the charged particle in the helical path. We call it as, basically this is nothing but the displacement of charged particle along the helical path. Are you able to get me or not? And it is the displacement of particle along the helical path when the particle is just going to complete one revolution, isn't it? Yes or no? So this is in the one time period, you should say. Are you able to get me or not? Yes. So let us write this formula of pitch. Pitch is like if someone asks you what is the this what is the you can say like what is the dimension of pitch. So basically it is like it has a dimension of length only. Are you able to get me or not? Yeah. So pitch is equal to the velocity along x direction, which is v cos theta, and in one time period, how much it is. Basically, distance is equal to what? Speed into time. So which speed is carrying it? V cos theta into time period. So basically, this is v cos theta into time period 2 pi m by qb. So this is why therefore pitch is given by formula 2 pi mv mv cos theta by, yeah. Are you able to get me or not? What is mv? Momentum of the particle or not? So pitch can be also related with momentum. V cos theta by momentum is root under twice m kinetic energy. Yes. But what? Why this? Actually, instead of pi, I wrote mass. 2 pi p cos theta by qv. What is momentum? It is 2 pi root under. You can write 2 pi cos theta into root under mass into twice of mass into kinetic energy divided by qb. That is also one more formula. So there are three formulas of pitch which I gave it to right now to you, and this is how you will remember it. Are you able to get me or not? Is it clear totally? So we got our radius of the path which is given as mv sin theta by qb. Then we got our formula of pitch also. Yes or no? Now let us define one more quantity which we call it as radius of curvature. What was the formula? Do you remember circular motion? What was the formula of radius of curvature? Tell me. What was that formula? Do you remember it? If this is a circular path, if this is a curvical path, and if this is my charged particle of mass m, then how to find the radius of curvature? How we actually used to do it? Can you hear me? Then how to find it? There, if I know the velocity of the particle at this point, how to find the radius of curvature? I told you first you have to take a small arc. Imagine a circular path over there. Yes, you have forgotten circular motion. Huh? Totally you have forgotten. Now, if this is my circular path and this is circular case, then what is radius? Radius of curvature is basically the radius of this small arc or not. Tell me some. How to find a small arc? Basically, if I know the perpendicular acceleration over here, if I know my perpendicular acceleration component, then we know that perpendicular acceleration, or we call it as centripetal acceleration, is v square by r or not. So basically, radius of curvature is given by formula any velocity square, and at that point, if you can find the perpendicular acceleration component, are you able to get me or not? So basically, here I can find ROC in the same way. ROC. I'm not finding radius. I'm finding radius of curvature. Why? Because here this is not a perfect circular path. Yes or no? Is it perfect circular? No. So I need to find it is a curve. Okay. So this is why we need to find the radius of curvature, total radius of curvature. So basically, v square. What is acceleration perpendicular over here? Tell me. Uh-huh. What is force? BQB sine theta. Mass into acceleration perpendicular. Basically, this force is working in perpendicular direction over here or not. Then only this particle is rotating. Yes. For any time, the charged particle is feeling perpendicular forces. So if I can find, basically this perpendicular force must be equal to QB sine theta. BQB sine theta. So MA perpendicular is equal to QB BQB sine theta. And acceleration perpendicular is BQB sine theta by mass. Can you understand this? So QBQB sine theta by mass M. VV cancel. So ultimately the radius of curvature is given as MB by QB sine theta. So you see the formulas are totally different. This radius is MB sine theta by QB and this radius is opposite of it. Yeah. Got it? Done? Now let's talk about one more quantity. Position vector of particle at any time. This is a curvical path. So I should know its, let's go if the particle is over here. So it has x, comma y, comma z or not. If I join that x, comma y, comma z with the origin, we call it as position vector r vector. Yes or no? So let us define position vector of the particle, charged particles, right? At any random time t. So r vector will be what? Xi cap plus yj cap plus zk cap. So what will be that equation? X is given by what? X coordinate is given by, you see that x coordinate is given by u cos theta into time t. Yes or no? Basically, let us change it to v. Okay. So it is v cos theta I cap. Y coordinate is, right now we calculated y coordinate. Y coordinate is r sine omega t. And z component is minus of r minus, so let us write j cap, minus of r minus r cos omega t. Let us write it in this form. Let's take r common. If I take r common, then what I'll be left with? Same thing. 1 minus cos omega k cap. So this is the formula of position vector of the particle at any time t. And basically, if someone asks you, what is the velocity at any time t? So velocity at any time t is nothing but dr vector by dt. And net acceleration at any time t is nothing but dv by dt or d2r vector by dt. This is clear or not? So this is how you are going to write everything for the case of particle when it is projected with some kind of angle theta. Let us write this u as equal to v. Okay, so this x is equal to also v cos theta into time t. Okay, so this will be the into time t. This will be the whole equation for the particle when it moves along a circular path. Clear? Yeah. So whenever I project a particle with some velocity v making angle theta with the magnetic field, It's not a perfectly circular path, but it's a helical path, and we defined everything for it, like position of the particle, radius of curvature. It's not even a circle, so we need to define radius of curvature at every moment. Okay, and then position of the particle and pitch of the particle. Got it? So let me give you one question based on this. Okay, let's suppose there is a region in which I have a perpendicular cross-sectional magnetic field, and when I throw some particles inside this magnetic field, we saw a deviation. We are injecting the particles over here, got it or not? Okay. Now, when the particles are injected with some velocity, it can be anything. Okay. So then these particles selects four different kinds of trajectory. One, hey, what is happening? Why your laptop is making some sound? Okay. So then the particles has four different trajectory. Let us call this as this is the trajectory of fourth particle. There is one more trajectory. Let us draw it red pen only. Okay. This is the trajectory of second particle, and this is the trajectory of our sorry, first particle. And one particle, yeah, and one particle goes undeflected. Now, these particles which were injected were, the question is simple, four particles, alpha, beta, gamma, and proton, are projected in a uniform magnetic field. Are projected in a uniform magnetic field with same speed as shown below. Are you making the notes perfectly or not, Srishti? Okay. Identify their paths. Tell me, which particle is following which path? Yeah. Identify their paths. Which particle will go undeflected? Which particle is following trajectory 1? Which particle is following trajectory 2? Which particle is following trajectory 4? Tell me fast. Okay, let us categorize. Let me give you one brief intro about the charges. Okay, is there any such uh, table is there? Ruler, triangle, calculator, everything is there, but table is not there. Okay, let us make it. Okay, let me remove this. Now, look over here. Try to see brief concept on our charges. I'm going to talk about five charges mainly, which comes into the exam and how they are denoted as. Okay, charges, their mass, their charge, and their identity. So let us select first. These are our particles. Then their mass, their charge, then identity. Let us consider first one, which we call it as alpha particle. Alpha particle has mass 4 AMU. Heard or not? Okay. Charge is plus 2e. It is denoted as helium plus 2 twice 4. Helium, this represents He24 represents helium atom. If I take two electrons out of it, we call it as alpha particle. Are you able to get me or not? Then beta particle, it has mass of the mass of neutron 9.1 into 10 to the power of minus 31 kg, and it has charge minus E. Okay, and identity is electron. So basically this is beta minus, you can say. Are you able to get me or not? Yes. Then there is gamma particle, the most dangerous one. It has no mass, no charge, and we call identity of gamma particle is almost like photon. Are you able to get me? Then I have proton, mass is 1 AMU plus E, and it is sometimes represented as H plus, word or not, iodized hydrogen atom. Are you able to get me? Then the last one is deuteron, and it has mass 2 AMU and charge zero, charge of 1 electron. And the identity is sometimes it is written as capital D, or sometimes just name will be given to you. Are you able to get me or not? So these are the points about our charge and their respective identities. Mention it. Okay. 1 AMU is then written as 1.67 into 10 to the power of minus 27 kgs, and 1 E means 1.6 into 10 to the power of minus 19 coulombs. Now, based on this idea, first write it and then tell me which one of these are these particles. Tell me fast. For which kind of particles Basically, the idea is simple. Again, this is velocity v. So the force is along v cross b. Yes or no? So if I can find the direction of v cross b, I know where the particle will, because these particles will deflect along the direction of force. Along the direction of force. If I first talk about first, let's suppose v cross b. If it is any charge, let's suppose if I consider when the charge is positive, the charge v cross b for positive charge. V is along j cap and magnetic field is along k cap. Inside I'm considering as k cap. So j cap cross k cap is what? I cap. Yes. Uh, inside, okay. Inside we have to consider minus k. So remember, inside we are considering minus k cap. Outside, yeah. So if a charge is positive, I'll get j cross minus k cap or not. What is this? Minus I cap. So for positive charge, the deflection is along minus I cap direction or not. For negative charge, this minus minus will become plus and charge will be deflected along right side. What's the problem with this? You got it? So basically, alpha, beta, gamma. Gamma has no charge, so it will go undeflected. So we know one case. The third trajectory is of gamma particle. Then fourth trajectory will be definitely of beta particle because it is only negative charge. Out of first and second, one will be of proton and one will be of alpha particle. Which one will be deflected more, alpha or beta, alpha or proton? So for that, we'll find the radius. We can find the radius of alpha particle by radius of proton. What is the formula of radius? Yes, find the formula. Find using formula. What was the formula of radius? mv sin theta by qb. Here sin theta is 90. Yes. So mass of alpha particle equation will be mass of alpha, velocity of alpha divided by charge of alpha particle into magnetic field. Magnetic field is same, divided by mass of proton, velocity of proton which is also same, by charge of proton into magnetic field. So these quantities get cancelled. So what I will get? Mass of alpha by charge of alpha into charge of proton by mass of proton. Mass of alpha is 2 AMU, 4 AMU. Charge of proton at that time is plus E. Charge of alpha particle is 2E, while mass of proton is 1 AMU. So if you look over here, then we can say that the relation of R alpha, radius of alpha particle is 2 times the radius of proton. Yes or no? So whether it is deflected more or less, I do not know. I need to find the radius equation. because deflected more is proton, but radius of proton is less. So basically, second particle is our alpha particle, and first particle is of proton. Are you able to get me or not? Clear? Hmm. Write this. Okay. Let us do one more question. An alpha particle and a proton are projected in uniform magnetic field. Got it? Let us write uniform orthogonal magnetic field. Find the ratio of their find the ratio of their find the ratio of their radius of the path if they are projected with first case, if they are projected with same, let me write same first speed, second time momentum, third time kinetic energy, and fourth time potential difference, accelerating voltage V. Okay, do this question. 1 minute. I'll bring water bottle. No, do it. You have to find the radius of their path if they move with same. Done? Should I help? Try it. Okay. Let us do now. First case, it is saying the radius of the path if they are projected with same speed. Radius of alpha particle and proton. First case, same speed. Now, right now we define radius of alpha by radius of proton. Yeah, it is. No, no. It is equal to what? Mass into mass of alpha. Once again, see that. Right now I told you mass, radius of the alpha and beta. Magnetic field is always going to be same in both cases. Now, first case is the velocities is same. Yes. So basically, what I will get? mass of alpha, velocity of alpha by charge of alpha particle into magnetic field of alpha particle in just reciprocal of same case, charge of proton, magnetic field of proton by mass of proton, velocity of proton. This got cancelled. Mass of alpha particle, right now you calculated it is 4 u. Let us write it as 4 am. Charge of proton is E. Then charge of alpha particle twice E into 1 amu. So this got cancelled. E got, it is 2. So if they are projected with same speed, the radius of alpha particle with proton, right now we calculate it is 2 or not. You said close to 1 or you said 2. Oh, okay. Sorry. I thought you said me close to 1. Okay. No problem. I heard that you said close to 1. Okay. Next is momentum. Ulta. Mass into velocity is momentum. Yes. So momentum of alpha particle by charge of alpha particle, magnetic field of alpha particle into charge of proton, magnetic field of proton by momentum of proton. This and this got cancelled. This also is going to get cancelled because momentum is same. Yes. Let me change this heading. Same momentum I have to write. Okay. So then this is charge of proton by charge of alpha particle. Charge of proton is what? E. And this is twice E. 1 is to 2. Correct. Very good. Third one, kinetic energy. Okay. Let us say R of alpha by R of proton. Momentum is root over twice M kinetic energy of alpha particle and kinetic energy of alpha particle divided by charge of alpha particle, magnetic field of alpha particle into charge of proton, magnetic field of proton divided by root under 2 mass of proton, kinetic energy of proton. This is cancelled. This got cancelled. So ultimately it is charge of proton by charge of alpha particle into root over 2 got cancelled, mass of proton, sorry, mass of alpha particle given by mass of proton. Yes. So basically when you will put it 1 by 2 and this is 4 by 4 by 1. So it will come as 1 is to 1. Yes. It will come as 1 is to 1 basically. No. Let me say uh, it is what? Charge of proton is E. Charge of alpha particle and mass. 1 minute. Why it is saying? Okay. Yes, correct. 4 by 1. So it is 1 is to 1. Yes. Then we have the last. So last, it's your task. I'll just write the formula. Same voltage or potential difference. We have to follow that. R of alpha by R of proton is, this will change as root under twice M kinetic energy is Q into V of, basically remember that kinetic energy of any charged particle charge into potential difference. Uh, Basically, this formula comes from, remember that potential difference is equal to work done by charge or not, or work done is equal to, yeah. So you have to follow that formula. Okay. So twice m. Basically, these all are of alpha particle. Let me write it perfectly. Root under twice mass of alpha particle, charge of alpha particle, potential difference of alpha particle divided by charge of alpha particle, magnetic field of alpha particle into opposite of this charge of alpha, charge of proton divided mass of proton, charge of proton, and potential of proton. This formula I have. Is that clear or not? So it will come as root 2 basically. Yeah. Clear? Now, whatever you do, this is the basically of radius. But as I told you, in all the cases, in everything, one thing is there same. That time period. Time period is independent of velocities or not. Yes. So if you look for all of these, just one time period equation. If I want to find time period of alpha by time period of proton, that just depends on their masses and charges. Got it or not? It is independent of this velocity factor. So if it is independent of velocity, it is independent of momentum, change in kinetic speed or something like that. Yes. So it is basically 2 pi m by qb. Yes. So mass of alpha, charge of alpha, magnetic field of alpha into mass of basically sorry charge of proton, magnetic field of proton by mass of proton. So this is exactly equal to 2. 2 is to 1. Are you able to get me? That's your answer. Clear? Any kind of doubt till now? Yeah. So let me write one question. One more question. A particle is orthogonally projected in uniform magnetic field B is equal to 100 microtesla. Okay. Find the radius and time period of motion. Got it? First case, if it is an electron, with kinetic energy 50 electron volts. Second, alpha particle accelerated by 100 volts. Is it clear or not? So if a particle is projected in a uniform magnetic field, orthogonal magnetic field means perpendicular magnetic field. Got it or not? Okay. Then find the radius and time period of motion if it is an electron with kinetic energy 50 electron volts, if it is alpha particle accelerated by 100 volts. Are you able to get me or not? That's your question. Try it. Okay. Hmm. Yeah, you have to do the question for alpha particle and you have to do the question for electron. Yes, you'll have to convert. We can think of a trick, but first try to do by conversion. Then only we can handle it. Okay. So try doing it. Then we'll see. Now we'll have only questions and questions and questions and questions. Okay. We have to solve almost 16 to 17 questions. Awesome questions I'll make you solve. Don't take tension. Then we'll go to cyclotron and then magnetic force on wire and then magnetic moment is there last. Got it. And then torque and moving coil galvanometer. So maximum 2 to 3 days topic it is. Okay. Let us finish within this month only. Right or not? Okay. Yeah. Okay. So you try doing this question. I'll share the solution. Right or not? And